Hello, hello. Are we streaming? Yeah, I think it's working. All right. It's been a while. Let's see. Is there anybody out there, though? That's the question. Anybody at all? Let me find these parts. 1019, 1019, 18. I don't have a 1019. Ah, 1019. Let me see what's different between 1019 and 1018. I have a feeling they're very close. Hello. Anybody out there? I don't see any chat at all. What am I doing wrong here? What am I doing wrong? One moment. Live. All right. Okay. Hello, hello. Oh, I guess I closed the wrong window. I see some people here. ROG ally? No, I don't have an ally. I do have one, but I'm not working on one. Hello, King Nothing. Happy New Year. Hello. I do have some power supplies to work on, so I thought I'd do a little short stream here. I bought this one off eBay, for a slim. And the guy I bought it from was interested in see how I fix it, so I told him I would do a video. So I'll do a live stream, and we'll just fix it on a live stream, and I'll send him a link to it, and maybe that'll be enough for him. But I've already pried it open, so you don't have to watch me struggle to pry the thing open. So it's already opened up, but I did damage one of these opto isolators doing it. If I can show you that, I did kind of let the screwdriver slip in there. And it's an EL1019, which I don't seem to have. I have EL1018s. So I was just looking up the data sheet for an EL1018 to see how different that is from a 1019. I think they are very, very similar. Little different what is it, CTR, the transfer ratio. But I'm going to guess I'm going to guess close enough for government work. 10, yeah, CTR. Okay. So I'll be replacing that with a 1018 because I have it on hand. So, yeah, we'll get that replaced, and then we'll get on with fixing whatever was wrong with this thing originally. Looks like I've already done a good bit of the removal already, unintentionally. Let me get this out of the case. I think I may have a PS5 coming in later. Oh, I think it's here now. Okay, yep. I think it's here. I was just checking to make sure I didn't have to go sign for it. Good day, sir. Good day, console crafters. Happy New Year to some of you in Australia. I know. Haven't quite gotten there yet here, but it's coming. Just gonna replace this opto isolator, and maybe then we can actually. The last time I pried one of these things open, I broke that same opto isolator. I guess because it's very close to the edge of the board, and it kind of sticks up, I suppose. That's my excuse. This could be a problem. Just noticed something. The one that I damaged is the one for the feedback. I can tell by that because of that Xena right there. You can see it. So we'll see if it works. I'm going to put a 1018 in here. If it doesn't regulate right, then I'll steal this one. Because these other two are basically being used as on-off switches. They're carrying a alarm, a shutdown signal from one side to the other. Not near as critical as this one. This one actually is what's handling the voltage correction feedback. And it probably kind of needs to be correct, but anyway. I'll try a 1018 in there. We'll see what it does. Let me look, come to think of it. Yep, 1019 is what's normally in there. I was just looking at my notes. So, I broke it. But I do have a whole thing of 1018s here. Looks like I have not used them all. How many's in that roll? Enough, apparently. Because I've never used these. I wonder what... I ordered these for a reason. So there must be something I work on that has them in there. One of these... Oops, and one fell out when I did that. I pulled the tape back and one fell out. Where'd it go? We have a volunteer. Here it is. Here it is. So we have a volunteer. A lot of unsteady audio. What is that, I wonder? Hang on. Is there something wrong with... is my wireless mic not working right? Let me move the receiver around. Sometimes I've wondered if the receiver has an issue sitting on top of the metal chassis of my computer here, but it seems to work fine most of the time. How is the audio? It seems better. I did move the receiver a little, but I mean, it also may be if I turn my head, the level's going to drop. The mic is somewhat directional, So as long as I keep my head in the same position, it's all good, but sometimes I do turn my head. Now where was pin 1? It's got to be this way. Yeah, because this is a feedback. Oh, it's also labeled there, but it's a feedback from the cold side to the hot side. That's your correction. We'll find out if this 1018 is good enough to make it work. But this is not going to be the only problem with it. I'm pretty certain it was. I bought it as a dead supply. All right. At least now we got that in there. Maybe we can give it some power. Or maybe we shouldn't give it power. Maybe I should just go ahead and check the controller chip before I bother putting power into it. Let's just do that. DAP053. I mean, I don't see anything. There's nothing burned in it. So there's no roaches, anything like that. It's just got a little dust in it. And I need to look around to make sure I didn't break anything else when I was prying it open. But I pried it open before I started streaming because, I mean, it takes me a while to get these things open. You can see why I slipped in there and damaged that a little, but no components were knocked off. Those are some cute current sense resistors. Hadn't seen those with that big white stripe on there. But hopefully I didn't damage anything else getting it open. Anyway, back to our DAP053. Where can I put this where you can see it? How about there? Welcome, welcome. Hello, everyone. My mic's a mess. What's it doing now? Sometimes it's good, sometimes it's not. It's clipping when I'm close to the mic. Clipping. Mic check 1 2 1 2. It doesn't look to be clipping on that in OBS. What about on the receiver? Let me. I've got a gain adjustment. Let me try. Don't do that. I was on minus 15 dB. Let me try minus 18. We'll go a little more. I keep passing. It goes in 3 dB steps. There's minus 21 dB. That's the output of the receiver. Let's see if that helps any. So I keep us from clipping. Oh, it's not clipping, it's cutting out. Why is it cutting out? I don't know. I tried moving my receiver around a little. I mean, this same mic I use when I'm recording. Hadn't had any issue. Check, 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 check. I see it kicking on the display up there. Looks fine. Of course, if it was dropping out, maybe I couldn't see it on the bar graph, but it looks smooth. Looks smooth as silk. Let's see how it goes. Did we just have a bad controller? That's my luck usually. Pin 1, 2, 3, 4 is ground, 5, 6, 7 is not used, 8 is good, 9 is good, 10 is good, 11 looks good, 12 not used, 13 shorted. Wow, 13 is shorted. That's the power supply into this chip. Pin 13 is the power supply. I lost my negative connection. There it is. 14, 15. 15 is also shorted. 16 is shorted also. Okay, so we just got a bad, that's going to be a bad chip. I don't think that, at least we have a bad chip. Maybe that's all of it. Maybe that's all of it. Did the audio get any better? Is it worse? Mic is good now? Oh, hey, there's Rusty Russ. Welcome, welcome. I know a lot of people are still watching Andy. That's all right. That's fine. Let me find my TEA 2017. I do have another supply to fix. Actually, I have two others to fix. If we'll get to them. Get this chip out. Well, welcome and Happy New Year to some of you. It'll be New Year soon enough here. Let's see if I can get this chip off without popcorning this board. If I'm lucky. Nope, turn that heat down. I try to keep 350. Seems to lessen the chances to popcorn. Where's my tweezer? Here, I was looking for my favorite tweezers. But yeah, the guy I bought this off of on eBay was wanting me, was curious about how I fixed it. I guess, like he said, it's something he'd like to do. So I told him I would try to do a video on it. Come on now. There we go. Let me add a little solder to this. Anyway, let's see. Made a little bit of a mess. Just a little bit of a mess. At least I put it on the right way this time. Well, hello, what are we talking about over here? I don't know of any ISP issues in the area. I have AT&T fiber. It's 1 gig up, 1 gig down, and usually pretty darn stable. Maybe it's smoothed out then. All right. Let's see. Can you see everything? Let's see. I've got that load on. I need to adjust it though because it's set for like 50 milliamps now. I was testing a little rechargeable battery that I was working on up there. Little rechargeable 9-volt battery. Oh, this is what I use in like some of these meters. And it quit working. I opened it up and there was a transistor had popped. And I kind of stuck one back in there and I was just checking its current capacity. But glued it back together. It wasn't worth fixing, but that's the kind of thing I do sometimes because I was curious what was inside of it. It's a rechargeable 9-volt battery. You put a USB-C cord in there, and anyway, I've got several of those I use. I've got some in the meters and some on the charger all the time. And I just swap them out. Let's see. I'm just going to set this. To 5 amps. Oops, 5 amps. That was a good starting point. It's on. Okay. I did not check the fuse. I bet you the fuse is good. The fuse very rarely blows unless we have a shorted MOSFET or something. Do I have that backwards? Yes, I do. Knew something didn't look right. The polarity backwards. And that DC electronic load does not like it when you reverse polarity on it. It does not like it at all. Oh, I don't have my meter for my test the boost voltage. Where's Worms? Haven't seen him in a while. Where is Worms? Do I have any new tools? I do have some new tools. I was going to show you. I don't know if I'll be... where is it? I got it over on the charger. Got a little portable oscilloscope / multimeter, but the oscilloscope is the part that I was looking at the most. That's also a signal generator, but it's a 200 megahertz. It's got 1 gig samples per second. But I wanted a portable scope for use on power supplies when I don't have them plugged into the isolation transformer. Like sometimes you want to test one. My isolation transformer, because it's the current limiting of it, I can only run a load of like say 12, maybe 14 amps output before I start exceeding the current capabilities of this thing. So, you know, if I'm going through the isolation transformer, I'll just use my regular bench scope. But if I'm plugged straight into the outlet back there, I want an isolated scope like this. I would not have it plugged into the charger or anything. I would just, and I have used it that way. I'm still working on that one that's got the PFC that's unstable. That thing is fighting me hard. Still working on it. But what else? I got some stuff for some wire. I got a bunch of nozzles for my hot air station. Got those. Actually, I put together an Amazon list for my kids is what I do. So So you know, that way I get things. I got 2 gallons of alcohol in the closet. It's going to take me a while. I got some, these are what I use for making my own test leads and stuff for this good flexible wire. Got some more of that so I can make me some more leads. Oh, what else did I get? Just, it was mostly stuff, you know, for the workbench. But yeah, I only had 2 angled nozzles. So I got an assortment of all sizes there. Straight nozzles don't really do me any good because I'm working under the microscope and you can't really use a straight nozzle very well there. So I like the 45-degree nozzles. Got those. Let's see. See if we can get this hooked up so we can monitor that boost voltage. And maybe tell if something's going horribly wrong. Can't quite get it to lay down flat though. With those connected. Yeah, maybe that'll work. Alrighty. That's in the way. So, voltage across our filter caps. I'm going to dial this way on down to 0. Bring this up. Voltage is coming up. Our fuse is not blown. Any current draw? Nope. So there's no deadly shorts or anything. Yeah, just checking the current. So at this point, you know, only like 60, 70 volts in, there's no current flow. But here in just a moment, she should start trying to kick over. Ooh, 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 ooh. That didn't sound good. Something shorted somewhere. Voltage went up to over 400 volts. Try that again. Let's see how high this went. I was watching. Let me see if we got any output. Yeah, it's trying to output. I see a little bit of, my arm's probably in the way. I see a little bit of output on this, not much. Yeah, this is bouncing around. It's not going too high, but that does not, it sounds like it's trying to start. What if I turn the load off of it? So see if it starts under no load. I don't think it will though. It's got a problem. Yeah, 1.3 volts. Okay, we still have a problem. Ooh, 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 ooh. 450 volts we got up to. I don't like that. I don't like that. Let's lead that off. Where are my capacitors? Right over here. Yeah, that's not good. So our boost voltage is going high. And we're shutting down also. I'm going to bleed this all the way down as far as I can. At this point, we're down to 2 volts. And I'll just stick a lead across it there if I could. All right. That didn't sound good at all. Let me go back to the readings. Oh, wrong chip. Let me go back to these readings again after replacing that chip. What did I do with my meter? Okay. Negative terminal of the capacitor. Can we see everything? 0.7. That all looks good. It looks good. I lost count. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, that reads wrong. Something's latched up. Once I touch the next pin, you'll see this go up to 1.4. So if I touch here and then come back, see, so something latches up inside the chip when you're probing around. All right, nothing reads crazy, which is unfortunate. Be very convenient if it did read crazy. Pin 3 reading 0.2. Is that normal? I think it is. I think I've looked that up before. No, I'm sorry. I'm looking at the wrong chip. Yeah, that is normal. That is normal on pin 3. 0.2. I think they're all in the ballpark where they should be. Nothing is jumping out. That boost voltage sure did go high. 4 is ground. 5, 6, 8, 9, 10, 11. 11.46, is that right? I've got 498. In the ballpark, 12. 13.7. Yeah, that looks fine. 14.61. That looks fine. 15 and 16. What about on our opto isolators over here? Let's check what those readings should be, because I don't have them memorized. Okay. Find my ground again. All right. Wonder if we got a bad DMP014 over there. It's a possibility. That is grounded. 0.68, that's fine, sounds fine. Here is OL and 0.7. Which one is that one? IC52. I think that's exactly right. Yeah. OL and 0.7. And here is OL. Wait a minute, that does not look right. 0.15. That is IC51, pin 2. That's definitely low. IC51, pin 2. That's one of those. It's one of the shutdown. If I can show you here. Yeah, IC51, pin 2. Should be 0.588. So that comes from this this MOSFET right here, this little Q33. And this is a common failure. It gets popped. Because if you see where it is, CQ33, if you look what it's connected to, it's connected back to the AC line. Right there's your AC line coming in. So there's some diodes and big resistors involved. But still, if you get a nice spike through there, you end up popping this thing. So, Q33, which shows to be an NX7002 VK. This is the version of should be marked T4R. Let's see if that's what's in this one. Sometimes they Q33. Sometimes it varies a little what they stick in the board. I guess that's that one right there. Is it? Oh, I thought I saw a crack in the top of it. Like there's some flux or something. Let me get it at an angle. Nah, it's just some flux. But I think she's bad. And I think I have a whole drawer full of them. 2N7002. I'm looking. I'm searching. 2N7002. Have I been replacing that with something else? It's the version of a 2N7002 that has a built-in protection diode from the drain to source, I believe it is. Or is it on the gate? I think they all have one from drain to source. Maybe it's on the gate. I gotta look it up. But it's just a 2N7002 with a little extra diode stuck in there. T4R. I honestly thought I had some of those. I'm almost certain I do. But they escape me at the moment. T4R. I have the one marked 704, which is a 2N7002 KT. I'm trying to remember if that's what I've used in the past to replace it with. Oh, no. I see something. Way up top. Which I need to move it down with the other one so I can find it next time. This may be it. Let's see what they're marked. Yep, there we go. I'll get one, you can see it there. T4R. All right. Let's replace that and see what happens then. That may not be all of it. Put that somewhere. What are we talking about in chat? Nothing? Chat has gone quiet. Or my chat window has stopped updating. I'm not sure which one it is. Let me get this changed. Like I said, this drives this opto isolator right here. So basically, it's probably kind of in a it's in a partial shutdown mode because of that, you know, MOSFET being stuck on. Which I'm not quite sure why it doesn't completely shut down. It kind of does this partial thing. Let's see if I can get this. I get this off here with just a soldering iron. Like if I heat these two legs up. I got anything in the shot? Yeah. Of course, it's glued down, remember? There it goes. There we go. That'll work. Where's my new one? Right there. knew I had some of these because I've replaced them before. What I need to do, I've got the label on the front of the drawer. I put, you know, the SMD marking code on the front of my on my label, and for some reason that one I didn't. I have the part number, you know, for the MOSFET, but not the little 3-letter designation. And that would have made my life a lot easier if I'd done that. I've done it on every other one, every other part. I have the SMD code in parentheses. All right, what's it going to do now? Kind of scared of the way that boost voltage was going so high. I think that happens sometimes though when it starts and shuts down, starts and shuts down, starts and shuts down. You end up with voltage building where it, you know, higher than it should. But since we did see it go high, we definitely need to watch. Watch for that this time. Because these caps are only rated at 450 volts. And it's not foam when caps blow up in your face. I've had it happen before. It's loud, sounds like a shotgun going off, and paper goes flying everywhere. Okay. Let me reset. I'm going to refresh this window here. All right. Yeah, I think we're ready. Turn this down. I'll try to keep my arm out of the way this time. The load is off right now. Let me go ahead and turn the load on. 5 amp constant current load. All right, bring it up slowly. Get this out of the way. I'm sorry. Get out of the way, microscope. Don't need you at the moment. Better. Better? I hope so. Nope. Nope, 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 nope. Still not working. That is not good. That voltage still went a little bit high. So yeah, we're still not working. And we will definitely discharge before we go any further. Before we go any further. Positive. I need to take a look at this DMP014 over here. The chip on the cold side. Do some diode readings on that. That MOSFET was definitely bad though. Like if we do diode checks there now on that opto isolator, we should have a good reading, I think, on this right here. Yeah, 0.598. So that fixed that, but we still, now we need to look at this DNP014 over here. Pin 1. Oh, I'm on the wrong ground. No readings if you're not on the right ground. Let's get on the cold side ground over here and try that again. Pin 1, shorted. Pin 2, shorted. Pin 3 shorted. Pin 4. I think there's enough shorted already, though. Yeah. So this thing took a nice strike. If it ended up getting the hot side and the cold side, I think that's ground there. That's not supposed to be ground. Yeah, it has a lot of shorted pins. There are many shorted pins on that chip. DNP014. Where are they? I may be running low on those. DNP014. DNP014. Wait a minute. Oh, I just found a drawer of the 1019s. So I did have some of those. I put a 1018 in this thing because I broke it. And I had 1019s. Okay. Couldn't find them earlier. Come on. Where are you, DNP014? I see them. I see them. There they are. Looks like I've used about half my supply of them, too. I think I ordered 20 of them when I got them some time ago. Oh, I see. Let me switch to live chat here. Hello, hello. No, my chat did not refresh. So I missed whatever it was. I'm sorry. It's refreshing now. I think I switched to live chat. When did you learn to do electron repair? What do you make? I probably won't be doing a class. I'm not a very good teacher, I don't think. I've been messing with electronics since I was like 16 years old or something. It's just I've gotten old. I've just been messing with. I enjoy it, and that's one thing I would have to say. I used to work with a lot of guys, who were trained in the military, and they were good with electronics, but it seemed like they just didn't have any love for it. It was a job. It was how they paid their bills. I love it. I just really enjoy it and love it. And I'm driven to learn more and to do more. So basically, you just learn by doing. You just do it more and more, and each time you work on something, and hopefully fix it. Even if you don't fix it, you will learn something. There's just. But I mean, game consoles are kind of new to me. I've only been working on those like 5 years now. And for some reason, I chose a PlayStation. When I started working on them, I didn't have a PlayStation. I remember my son having a PlayStation. Growing up, when he was playing, he's playing with the PS5 right now, probably at home. But that's why I started doing PlayStations, though, because it's the first thing that popped in my head. Let's try PlayStations. And this was back during COVID. And I got into it at just the right time, I guess, because people were at home, bored, looking for something to do. And I started buying broken PS4s. And I couldn't fix them fast enough. They were selling so fast. But I got where I just enjoyed it. It's satisfying. It's just always been satisfying for me to take something that does not work. It's not supposed to work ever again. It's garbage. And you turn it into something that has value again. Extremely satisfying, and there's a lot of people out there, I'm sure, that are like that, have that same feeling. It's just very satisfying to, you know, to fix something, to bring it back from the dead with a little bit of knowledge, a little bit of ability, a lot of spare parts. I don't know, just a very satisfying thing for me. So it's kind of become my hobby. And it's a hobby I managed to make a little money at. Not as much as the government thinks I make, but a little. You know, the government thinks all that money I got in was all profit. No, 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 no. I had to buy a lot of broken items. Probably should have removed some of that glue so it set down better, but oh, it went down. It sat down just fine. I think I may touch that up. And this flux is just cheap Kingbo flux. You buy it by the tub. It's not the world's best flux, probably. Um, you know, it smokes a little. It will burn off if you take a long time. You know, to get off to put something on, you take a long time with the heat on it. But it just works for me, so I keep using it. I use it for reballing VGAs. It's the only flux I have on hand. I'm sure there's better fluxes out there. I just kind of gotten used to it. I buy the big tubs of it, you know, which is, you know, it's probably made in China. Knockoff, even though it says Japan, it's probably made in China. I'm sure it is. And I put it in these syringes myself. I got the syringes off of Amazon. I fill up a syringe and off I go. All right. I'm just curious now. Before I give it power this time, did we get rid of all those shorts around that thing? I would imagine we did. I would imagine we did. That was lightning just had its way with this thing. Pin 1, 2, 3, 4. That's 4, yeah. 5. Oh, this is good. 6, 7. Beautiful. 8 is ground, so that's fine. 9. 9 is a low reading, and I think that is normal. I think that's normal. 0.1. I think that's normal. No, that seems low. According to what I've got here, should be like 0.305 on 9. What is that connected to? Well, there's a couple capacitors there. It's connected to the output. So you get a low reading there sometimes because all these capacitors are discharged, but 0.305. All we have there is some caps on the line. There's a 100 ohm resistor in series. Well, okay, sorry. Then we go over here too. We go to the opto isolators. So maybe I need to look at these opto isolators. Do a quick check on those diode readings. may have, that just seems low. Seems a little bit low. Beta VC. You're working on an old beta VCR? I don't know. It may be available. Oh, there's Andy. Well, hello, hello. Well, there's Worms. Hey, Worms, I thought you were gone. It's good to see you, Worms. I feel better now knowing you're here. Let's get on with this repair. This is one I bought off eBay. Some of you are just joining me. Every now and then I do a crazy thing like that. I'll just buy a broken one off eBay. And the Slims is, I have the least number of the Slim models. So I'd love to get my hands on some more of for the Pro, the PS5 Pro. Those are hard to come by. I have one that I bought for reverse engineering. It works. It's around here somewhere. But I haven't been able to find any other. I guess I haven't sold a lot of the Pros yet. I'm going to look around these opto isolators. 0.6 and 1. 0.6, 2.28, 0.6, and 0. Let me go back to this first one. I see 53. 0.6 on pin 2 and 1 volt on pin 1. IC 53. That's the one that's the feedback for the voltage correction. Alrighty, 6:30. Thanks for coming by. And Happy New Year to you. Let me go look. What was I looking at? IC 53. IC 53. Okay. 1.23 and 0.664. 1.23 and 0.664. And what was I getting? 628 and 1. That seems a little bit off. We don't have a short on the out. Oh, you know what? That's going to be. I just realized what it is, I think. Yeah. The reason that's reading low is because my DC load is hooked to this thing. So there's a electronic short across the output terminals right now. So let's unhook that and see what we get now. What do we get on that pin 9 now? Yeah, now we're charging up. That looks normal. And up here, yeah, okay. That's what that was. My DC electronic load was causing me to have a low reading. That was that issue. We're ready to test again. We replaced that DMP014. It was shorted all over the place. Let's see if she does anything this time. Let me get my scope out of the way. Load is on. I'm going to dial this down. I think she's going to do something better this time. Let's see. I'm trying to make sure I keep my fat arm out of the way. Hey. Yes, sir. 396 volts. We're putting out 12 volts here. That seems to be a little bit high. Let me check the meter. We must have like 12.1 right here at the terminals, because we've got across these wires, I'm getting 12068 over there. I was kind of surprised by that. And what do I have right here on the output terminals? 12.12. Running a little bit high. You know, I think what I'm going to do, though, if you remember, some of you may have missed the very start of the stream. I pried it open before I started the stream, so you didn't have to watch me struggle to pry the thing open. And I ended up breaking one of the opto-isolators. And the one that I broke is the one that handles this feedback correction voltage. And I could not find the exact replacement, which was an EL1019. I put an EL1018 in there. But I have since found the 1019. So that may be why our voltage is running a little high, though, because that the current transfer ratio is not quite the same between the two. They're close. As you can tell, it works. So 12.129. All right, we're going to swap out this opto-isolator to the correct one, because I broke it. I jabbed a screwdriver in the side of it, prying it open, and broke it. So it's working. Yes, it is working. Yeah, the lobe was fooling me. And I've gotten fooled the same way working on a power supply. Like this, I'll leave it hooked up to my variable AC transformer. And I'll be measuring a short on the bridge rectifier, and I can't figure, why do I have a short? It's because it's hooked to a transformer inside this thing. And when you turn this off, you're turning off the input to that transformer. I'm still hooked to the secondary of that transformer, and it's a DC short. And I've done that before. Chased my tail just a little bit before I figured out where the short was coming from. All right, let's discharge this thing, and we'll swap out this opto-isolator and see if that gets our voltage down. It'd work fine like it is, but I'd like to see it a little closer to 12. Where is find my capacitor here? Okay, we are now safe. Can I do this without taking everything loose? Try and get a little closer to it here. All right, so this is what I could not find before, was these EL1019s. I thought I had some. I thought that I had, you know, when I took, the first time I took one of these slim supplies apart, I made a note of the parts that were in it and made sure that I had them on hand. Opto-isolators, you know, these two ICs here, these MOSFETs. I should have all that stuff, the common stuff that fails, the fuses. I've got a drawer full of those, and for whatever reason, I could not find these 1019s to begin with. All right, let's get that thing off of there. Maybe we'll just do it with the soldering iron like I put it on. Let me get my fan going. I don't like the, I don't want to smell the smoke, and also don't want it going up in my microscope, because I've had to, at least twice, I've had to take this microscope apart and clean the glass and the mirrors inside, because it puts a film on them, and you get kind of a hazy, you know, look through the microscope. All right, am I turning this the right way? Got a 50-50 shot. I think it's the right way. I'm not sure if you can see it. There we go. But here's pin 1 marked on the board. Oh, come on. I'm trying to get it perfectly straight. Yeah. Anytime you try to get it perfectly straight and keep messing with it, you'll mess it up. Alrighty. I am curious if this does anything. Because the clean the output voltage is pretty well set, you know, by this DNP 014, which we have replaced. It's basically set by that chip right there. It has a reference in it. Everything that used to be built out, you know, individual components on the earlier supplies, they put it all into this DNP 014. This handles the over current protection, over voltage protection, all that stuff. And there's a solder ball just kind of hanging out right there. Let's get rid of that. So the voltage is basically set by, you know, this chip driving this. And what I'm hoping is I had a 1018 in there, so that current transfer ratio, the ratio as far as, you know, how much drive here, how much change you get on this side is going to be different. So that's my hope anyway. That's my hope that gets our voltage down just a little bit. All right, let's try this again. Microscope, get out of the way. No, you're still in the way. All right, I think we're ready to check. I'll get this meter over here for confirming the voltage right out of the supply. What are we talking about? Hello. I am Raj. Hi. Yeah, I don't have a Barlow lid. I guess your Barlow probably catches all the fumes for you. All right. Load's connected. AC in is... Start off. We're still at 5 amps here. We know it's going to run. We just need to know what the output voltage is. We know it's going to start. Oh, look at there. That's 1206. That still seems high. That still seems high. 12.12. Did that come down a little? I've already forgotten what the voltage was. Was it like 12.14 earlier? So, I think we're fine though. I would like to give it a little more load and see what that voltage does. There's 10 amps. What do we see here? 12.12, holding pretty steady. All right, I'm going to turn this off. Boost voltage looks beautiful. I'm going to go straight to the wall outlet. Hope I don't trip a breaker, which I've done before. Killed all the power to my little room here. All right, so now 10 amps. Let's run it on up. 15 amps. It's 20 amps. I hate when I drop my probes. I just bent the tip. Yeah, I sure did. If you drop something, it always lands right on the pointy tip. Look at that. So I need to grind it off. I sharpen them on some sandpaper. It landed right on the tip. Just my luck. .109. I think that's going to be just fine. I'm going to run it all up though to 5 amps. It's going up to 31. There we are. 31 amps. That is her rated current. 12.096. Bring her on down. Alrighty, 10 amps, 5 amps. But it looks good. This is staying rock solid. I like to see that. She's fixed. Now I need to move on to another one, I guess. Hello, Simon. Everybody just running over here? I do appreciate it. Yep, I always load test every one of them. Oh, there's JFix. Hello, Carthor. Hello. The gang is all here. All right, so let's. I'll put this one to the side, and we'll move on to another one. So, anyway, this is the one I bought off eBay. Unplug it. And now we have another good spare. Let's discharge it. So we ended up replacing this DAP053. I put a TEA2017 in there. We replaced this Q33 MOSFET right here. And we replaced the DMP014. And we replaced an opto isolator because I physically broke it getting the supply open. I'm going to discharge it before I try to handle it because of reasons. Don't want to get bit. Don't want to get bit. Put you right there. I got a lot of parts out right now. I'll just slip this back together. I'm not going to snap it together right now. Looks like I need to blow some dust out of it. But yeah, I pried this one open before I started the stream just because it's, man, they are a pain. I do have another one to fix. I just don't know if I want to pry it open right now. I've got another 400GR to fix. It's going to have roach damage because the PS5 I took it out of, I had roaches in it. So I know it's been killed by roaches. And I just swapped it out and laid it to the side. That's this one. It's gonna have some dead creatures in there. So, but I know I do have another 400 ER. I believe this is a totally dead one. I had some post-it notes on them, but the post-it notes kind of came off. So let's just double check it. Post-it notes don't stick too well to these things. I believe this is a dead one though. 5 amps. Yeah, it didn't try to start. You didn't see that voltage dip down. So it did not try to start. This one is dead. And these, where did I put those screws with that other supply? Here they are. These are not too hard to get open. Lay those screws. I'll put you together later on. Let's see. These are really easy to open. Now it seems like. For some reason, I always start in the same spot, right in here. I said they're easy to open. I said they're easy to open. And somewhere, that's something else I did get as a Christmas gift. I got some more of these pry tools, and I put them in my drawer over here somewhere. It may still be in a bag, but because I had used these so much, I bent them. They started to kind of, permanently bend. So it's probably time to retire some of these. I don't remember. This one must have been in a PS5 that I picked up to work on. Oh, I see a burn mark. Oh, I see the top blowing off the DAP053. Yeah. Does that show up on camera? Yeah. So, yeah, I'm guessing some lightning damage on this one as well. What do we think? You can see what's left of the structures in there. Kind of cool. I'm sure some of that was some transistors. Kind of neat. I'm trying to zoom way in, but it gets shaky. And the light kind of dims down. Going through a lot of glass at that point. Anyway, I just thought it looked kind of cool. But I think its days are done. So I need... first of all, some DAP053s. I'm going to use an original. You can use a 2016. I just like to use the original DAP053 if I have them on hand. Go. So, is that all it got, though? I mean, it took a pretty good hit, looks like. Is that all it got? Oh, now we're retracting messages. Oh, no. The unstable. No, I have not. I have been working on it, though. I have not forgotten about it. And I've been using that new, my new portable oscilloscope to work on it. It's over here, and what I have started doing, where is it over here? This is the unstable one here. I've started swapping out parts with a good one. Set them side by side. I've started on certain capacitors. Stuff in the feedback circuit for the PFC voltage and, some of the feedbacks for the 12-volt generator. Anyway, I've just been, the suspected areas, I started swapping out parts, and that's what I'll go back to it, and I'll work on it a little bit. If I have nothing else going on, I will get it out over here and start swapping out parts. We're going to find it at some point. I hadn't forgotten about it. Had not forgotten about it. Let's see now if we can get this chip changed out. But I took quite a few capacitors off and checked them, because I was kind of suspecting the capacitor had broken down. Ooh, speaking of a capacitor that's broken down, look at that. Look at that. We got one here blown. Got one here blown. We got a Zener that's popped. Wow. I have to find a parts board. I'm pretty sure I don't have. I have to take it off a parts and donor board. Yep. Lightning has popped around in this thing a lot. It means our MOSFET's probably bad too. Our big MOSFETs, we'll check them. See what I'm going to do, I think, is pop this off, and then I'll do diode checks on each pin with the chip off here. Before I put this new chip on there, let's just do some checks. I didn't know I was getting another lightning damaged one here. All right, what do we have on what pin 1 is? My poor lead. I have to grind this thing off. No reading. 2, 3. Ground's normal. 5. That's low, of course, because it's probably hooked to one of these shorted Zeners. 5 is low. Keep that in mind. 6. 6 is also low. 8. 9 is low. That's going to a MOSFET, I believe. 10, 11. 11 is shorted. I wonder why. Could be the cap there in pieces. 12 is no connection. 13, 14, 15, 16. Even 16 is a little low. 0.27. Oh, I see a burned resistor right here. See this 30 ohm resistor? Has a hole blown on the top of it. Yeah. That's nice. I probably do have those. What else did we pop? I bet you we popped. Oh, we popped that right there. Q30. Which one is that one? Okay, it's going to be Q31. The labeling is, it gets kind of confusing. The labeling's up here. R34, Q31, R34, Q31. And this is Q32. That's the one that was blown on that last one we worked on. And it's probably blown again. Let me check down through here. No reading. No reading. Of course, our chip is off the board. That's low. That's low. Oh, we got all kinds of problems on this thing. Surprised that's not shorted. That one right there. Very surprised it's not shorted. Okay. We know we've got a bad Zener here. A capacitor that has melted. C85. What about this 2.74 ohm resistor here? Well, let me get out diode check. She's fine. What about some of these Zeners over here? Go back to diode mode. That's low. and that seems low. I think both of those may be gone. I'm just hitting some random diodes I see. What about these MOSFETs? These are the MOSFETs for the 12-volt generation. 0.115. Yeah, that's not good. That is, I believe that's Q3. Yeah, Q3 is shorted. And this is Q4, also shorted. What isn't shorted? How about the MOSFET for the PFC? Well, I'm not sure on it. The PFC diode seems fine. This may be bad. That seems... Let's see, where's the gate? Where's the gate? This is the gate. Drain source. Gate. 180 ohms from the gate to the source does not seem right. Not at all. So it's probably bad as well. I need to see, do I have these parts here, these capacitors? And that M2 Zener. Oh, I think I should, let me find a donor board. Well, everybody's showing up suddenly. I know I have a donor board, right? Well, I have a couple of them here. There's not a whole lot that's good on this one, though. Yeah, this one is, it's seen better days. I wonder, I think I've already stolen a capacitor off this thing, though. Yeah. And I may have already stolen it off this other one. Let me see here. This is an FR. Yeah, I've already stolen C34 off of this one. I'm going to have to come up with a C34 somewhere. Because best I recall, that's a rather important capacitor. Is it C34? Yeah. C34 is over right there. If you read the data sheet on this chip, the way they do it, they're using the low side to boost the voltage to the high side, because you need a pretty good voltage to drive the gate of that thing. And this is part of the circuit that does it. So, yeah, it's kind of important. That's what this diode and capacitor arrangement is here, because that is the feed to the high side MOSFET. Oh boy! So that's like it's like a 360 nanofarad, and I'm not going to have one. It's also probably pretty high voltage. That may get us. Not having that. Unless I have another one somewhere to steal one off of. Okay, let me just start taking some burnt stuff off. Come on. Don't be welded to the board. Okay, it's not. Just glued. Now, this one looks like it might be welded. Nah, she popped right off of there. M2 Zener. They came apart. Came apart. I need to get that last part off of there. I guess I could grind it off. May have to grind it off. What's left? Oh, just some glue. M2. M2. I think I've got to dig through a tub of parts. From my PS4 repairing days to get to that M2 diode. May need one of those also. We'll see. All right, let me stay focused. Don't get squirreled. M2, M2, M2. I could pull it off the donor, I guess. If I don't find it, I'll have to. J1. This is a whole tub of parts that I used when I was working on PS4 power supplies, which I haven't really worked on one in a while. But I still have a lot of the parts. K2. Close. M2. J3. 18 volt Zener. A bunch of MOSFETs. A2, which is just a 4148. I don't see an M2. Unless I've got it. Unless I've got it put up somewhere I wouldn't, forgot that I put it up there or something. I don't think I've had to replace that a whole lot though, so I don't know that I have it. I don't think I've ever had to replace that part before. But lightning does whatever lightning wants to do. All right, let me pull that Zener in one of these capacitors if I've got one. So this M2 Zener and C85, I can get those two. Let's get those and we'll go from there. That's all I can do at this point. Why did I put, anyway, I put flux on the capacitor instead of the Zener. Okay, got the Zener. Got our capacitor. And like I said, I already stole C34 off this board though, unfortunately. So I'm going to have to find one somewhere. Steal one temporarily or something. Also got that 30 ohm resistor we got to replace. And we got some MOSFETs to change. And that's just what we know. I'll come back, don't lose it. Sticking to my tweezers. Alright, which way's, oops. There's so much flux on it I can't see the stripes on it anymore. I can't tell which way to turn it. Where's the stripes? Oh, wrong way. No, that's the right way. Sorry. That's the right way. The line up here is the cathode. Oh, come on, straighten back up. And I wonder about this other Zener. That one right there. A lot of these Zeners, I'm afraid, are going to be, if they're not shorted, they're not right or something. Now that one reads open. ZD36 is blown open. ZC. That's its number, its letters. You can read that. ZC. It's open. Which is in that same circuit as that 30 ohm resistor. ZC, do I have that one? I have a ZM. I can see that already. I do have the ZCs. Oh, and there's the M2s. Now I see the M2 drawer up there. Yeah, couldn't see it before. But when I'm not looking for it, I can see it. Strange how that works. So, yeah, ZC. What are we chatting about over here? You getting food, worms? Am I muted? I don't think so. No, I see it. I see the bar graph kicking up there. I'm not muted. I am thinking about getting something to eat myself, though. Just thinking about it. Guess I need to hurry this up, don't I? Let go. Grab a new one. Looks like I have used one out of this strip of 100. Come on now. Let's turn it the right way. Oh, and then it left the country. Come on. Stay right there a second. I think I moved my tweezers and flipped it. Right there at the very end. That doesn't look very nice. That's better. What else is open? I wonder if any of our 0 ohm resistors are opened up. We know we got that 30 ohm resistor. It has to go. All right. Now let me find. That's a. Is that a 1206? No. 10. Hang on a second. Okay. I'm looking through my resistors. I thought I had some of those. I'm searching. This is an 0805. Yeah. Just got to find a 30 ohm resistor in this pile of them. It's not a book, it's just a pile of them. But they are marked. It's a bit of a puzzle. 82K, 47, 139 ohm, 150. How long is it going to take? 22. 10K, 200, 220, 30K, 120, 12, 51, 100K, 62, 4.7, 1.5, 22K, 33K. What is that, 390K? I'm searching. "30 arms." I found it. I found it. Let's see if this will work. So it's an 0805. Oops. Just don't put the old one back in there. All right. So we've got that. We're still missing C34. Let me go ahead and put this DAP053 on here. But we know we've got bad MOSFETs too. Glue is holding it up. Okay, so I know also that we've got, here we have some bad Zeners up here. Yeah, that's not right. Yeah, I think both of those have broken down. Let me try lifting these. See if I can spin it around. Just kind of sit right, no. Stay right there a second. Oh, now we're getting 0.6. Well, maybe it's just because the MOSFETs are shorted. Maybe that's the case. I'm going to leave that there for now, but let's go ahead and let me remove these two MOSFETs and just see if our, I think I'm just going to do this with a big soldering iron. See if these other shorts disappear when we take these MOSFETs out. There goes one. And here goes the other. Now, with those out, the PFC may also be bad. What kind of reading are we getting across this Zener? Yeah. That looks normal now. That still seems low right there, though. So, across this one, 0.7, if I go to the pad, that looks fine. This one still reads low, 0.1. And that is on pin 1, 2, 3, 4, 5. Pin 5. The resistor's good. Pin 5. What does pin 5 do? Off the top of my head, I don't remember. 1, 2, 3, 4, 5. See a 100 ohm resistor coming in. Is this ground? Yeah, so that's ground. So this is limiting whatever this signal coming in here is to this 100 ohm resistor. So this one may actually be bad. It's going to blow away. I'm going to put it back down. Oops, and it left. I see you. This one is marked ZJ, I believe. And it goes here. If we turn it the right way. And we hold it. Oh, left again. Nope, not that one. I kind of need that Zener. Where'd it go? Is it on the board? It went off to the left. I know eventually I would lose the thing. It's got to be here somewhere. I mean, how far could it go? Well, pretty far, apparently. I don't think it's this one, is it? I've got several parts on the board now. What is this one? No, that's that ZC one we popped. And this is a ZM. Where's that ZJ? And do I have a new one if I can't find it? Oh, oh, oh. Up next to the bridge rectifier. Now, where did it go? I believe it went on the left here, if my memory is any good. Which way does it go? I'm going to get a hold of it. I'm going to let it blow away. Okay, that's the wrong way around. Okay, that is the right one, right? It should be the one marked ZJ. Yes, it is. So I need a new ZM. I think it was ZM. What Zener? That's ZD39. It's got a little legend off to the side there. ZD39. ZD39. Right there. It is ZM. Most likely an 18 volt, looking at the part number. Do I have one? I do indeed, I do indeed. I have so many little bins out on my desktop now, it's getting a bit crowded. I've never used one of these. All right, those have been replaced, or one has been replaced. Still missing C34. I gotta find one. I don't know where I'm gonna find one. So what about this PFC MOSFET? Is it still looking? Okay, that looks right now. So something was giving us that shorted reading earlier. Could have been one of these Zeners I've taken out. That's ground. 0.6, 0.4. Okay, our PFC MOSFET may be just fine then. Huh. Did I check this Zener? Yeah, it's fine, I think. Diode looks fine. What do I have now over here on these opto isolators? That's low. That's low. 0.26 is low. Oh, we still got this one here with a hole in it. A little extra ventilation it's got there. Okay. That I know, this is going to be a bad Zener, I believe, right here. Because this line, just basically you have that Zener to ground. This is the feedback for the voltage correction. It only goes past the Zener straight to the chip, straight to the DAP053 over there. There's nothing else in the line. So if it's reading low, either the chip over here is bad, which we replaced, or this Zener, which is a 9.1 volt Zener, has broken down. And I do have some of those. But we do need this chip. This is that ZEW. This is an NPN transistor. It's not a MOSFET. ZEW or ZEW. That is it's kind of a regulator for the voltage for that DAP053. And its regulating days are over. I was just hitting some of these diodes down through here because I fully expect to find something else shorted. 10 ohm resistor's fine. All right, let me change that out. I'm going to have to put some parts bins up. ZEW. ZEW. Here they are. Got it. Need one of those. This is the same little transistor they used back in the PS4 power supplies. I remember that's why I have them. Let's get it off of there. Still got to find that capacitor, don't I? And I got to put those MOSFETs back in the big power ones for the 12 volt generation. And I should probably check the oh, it broke apart. Should probably check the bridge rectifier. And the fuse is probably blown. Oh, come on. The fuse is probably blown, and for good reason. And if those MOSFETs shorted, our little 0.1 ohm fusible resistor is going to be open. The glass ones, I don't know. I don't know why they use those. Never have figured that out. Why they prefer this one, but I'm pretty sure that's bad. That is ZD35. I'll show you that. ZD35. Oh, it's on the right here. The opto oscillator for the feedback. Right there. Yeah. Look at the part number 9V1. So it's a 9.1 volt Zener. And so that reading right there on that point should be 0.6, and we're getting And if you look at where, where it's at the line, see this is the feedback signal. You can see where it comes across. There's that zener to ground, and it goes straight to pin 16. There's nothing else on the line. So if we've got a low reading, it's got to be that zener. So let's go ahead and swap that out while we're in here. Yeah, this one definitely has been visited by lightning. So much damage. All right, cathode's on the bottom. No, when I was digging through these PS4 parts just a moment ago, I saw that 9.1 volt zener. I haven't replaced a bunch of these, but, well, actually half the strip is empty. It even landed the right way around. So now that diode reading should be much better. Let's see. Yeah, 0.55. And it's going up because it's cooling off, so 0 and 0.5. Should be about 0.6. Yeah, when it cools off, it will be. So that's good. What else did we pop, though? We replaced this one. Need to put the MOSFETs back in there. Where's that fusible resistor? Because if the MOSFET's shorted, yeah, it's open. See it right down in there. Okay, so I need a resistor. I need a couple of MOSFETs. I still got to find that capacitor, and that could be the killer. 0.1 ohm resistor. Got that. And I need a couple of these. Find my solder wick. I'm going to say we got a charged cap there. We did have a charged cap. Whew. That got your attention. I'm awake now. Did I not discharge this thing? Where's my capacitors? That was a lot of pop there. If I didn't discharge this thing, how have I not gotten shocked as much as I've handled this damn thing? No, there was a little bit there. Of course, I guess I discharged it then. Wow. So what did I damage when I did that? Fun, fun, fun. Negative. Well, there's 2 volts there now. That'll get your attention. Yeah, okay. Hmm. Cutters, cutters. MOSFETs. See if I can tack these down. What else? Oh, the fuse is probably blown. And then there's the bridge rectifier we need to check. Where's the fuse? We're still, okay. And the fuse survived. The fuse survives all. And our bridge rectifier, does it survive though? Not getting any shorts. I'm going to guess he survived. The fuse survived. How are we looking now around this controller, DAP053? Replaced a lot of stuff. 9, 10, 11, 12, no connection, 13, 14, 15, 16. That's looking good on the opto isolators. Looking good. Looking pretty good. Except we still need a capacitor. We still need C34. C34, which is 350, 360 nanofarad. If I had one, I probably wouldn't have one of sufficient voltage. Now, there can't be much voltage there, because that IC wouldn't withstand 400 volts. Still, if I had anything, it would probably be like a 25 volt or something. Is there a C34 left on here? It's not looking promising. I think that was C34 right there. Is that C34? C34 goes across pins 10 and 11. There she is. There she is. What are we talking about? I was trying to hide. Hello. Yeah, there was a spark earlier, but I never plugged this thing in. No, I did plug it in. Excuse me, I did plug it in to make sure. Oh, Tom Morgan, yeah, we're going to fix this one next. Yeah, this is next on the. Yeah, that's the next one. I do have one I want to try to fix that's had water damage. I've got it marked over off to the side. I've opened it up and I've looked at it. But it does have significant water damage to it. It's going to need a lot of work. It's getting to be my lunchtime. Gotcha. This is from a different revision board. This is from I think this is a DR, 400 DR. But they use a lot of the same circuits in both of them. That's why I knew it would be one there. I want to do a quick check of its value. Should be like 350, 360 nanofarad. It's a little bit warm right now. $342 nanofarad. Yep, I think that's it. Well, Forgot where I laid it. I laid it over off to the side. Maybe a little bit of flux. You know, my camera's a bit overexposed. I'm sorry about that. Let me check, because you know what I figured out? This new TV I bought, apparently the remote for that thing will activate the menus on this camera. And so without my knowing it, I end up changing the exposure or doing something else. Let me try this menu. Except I can't see it from over there. Just a second. Just a second. It's bothering me now. Exposure. Yeah, it's raised. That's why it's okay. It just keeps happening, and I know it's got to be because of that. I need to cover up the receiver on this thing. Yeah, maybe we'll go up one notch. What do you think? But it keeps changing on me. I know I'm not changing this. How is this happening? Oops. Exposure. Nope. Hit the wrong button. Yeah, I like that. All right, let's get out of the menu. Okay. Yeah, I keep accidentally changing it by using a different remote on a TV across the way there. So I need to just cover the sensor on this camera because I never use the remote for the camera. I just, you know, well, once you get it set up, there's not much to change. All right. That was the last piece of the puzzle that we know about. That does look better, doesn't it? It does look much better. Now, it's the stuff we don't know about. Don't see any more shorts around the chip here. I have not even looked at the cold side of this thing. That solder looks kind of odd on that resistor, doesn't it? I have not even looked at this side. I'm kind of hoping this side, you know, was isolated. But I wouldn't bet on it. Well, I'm not seeing anything too crazy. It all seems to be within reason on that IC. Where's the other IC? The one down here that handles the rectification. Synchronous rectifier. I think that's normal. Okay. No, I don't see any components with the top blowed off of them on this side. And we don't seem to have a short on the output. No, no short on the output. Maybe this side was spared the damage. Although that jumper looks weird. She's not open. Well, we are approaching the point of trying to plug this thing in, which is kind of scary, as much damage as it's had. I haven't cleaned up all the flux. It's still a mess. These large diodes around here. Well, is it time? I've got a pile of parts over that I replaced in this thing. Have I forgotten to put anything back? I replaced that little capacitor, replaced that 30 ohm resistor, Zeners are back. We don't seem to have any shorts in any of the major places. Okay, I'm going to give it a little bit of a juice. Let's see if we get, I'm going to watch the current draw real close on my variable supply over there and see if it starts going into the silly numbers. Get some stuff out of the way. Oh. All right. Set for 5 amps. We're metering our voltage across the capacitors. Gonna wind this down to nothing. Power's on. We ease it up to like 20 volts there and check the current. No current flow. How about 40 volts? I'm not getting any rectified DC though. So, yeah, that voltage isn't going somewhere. Something is open. Our capacitor voltage isn't climbing. I thought that fuse was good. Oh, the cord's not plugged into the damn thing. Did somebody notice that? Did anybody tell me? Load on max? No. Anybody, no one noticed that I didn't plug in the AC? That's your job. Keep me honest there. All the way down. Plug it in. Now let's see if anything different happens here. That probably helps a little. The cord is trying its best to get in the way. I'm tiled all the way down. I'm only on 5 amps of load right now. Now do we get some DC voltage here? We do. Do we get any current flow? No, nothing yet. 40 volts AC in. Still no current flow. So there should be no crazy shorts on the input side anyway. All right, somewhere up in here, she's going to try to take off and run. Or go up in smoke. Oh, we're starting and shutting down. So we still got a problem, but we're close. Wow, ooh, We went over way over 400 volts, didn't we? So we're still shutting down. It was trying to start though. It was trying. All right, did anything short? I doubt it. Just gonna look at this DAP 053, make sure nothing went short when that's ground. Pin 5, pin 6, pin 7 is no connect, 8, 9, 10, 11, 527. Is that normal? 12, 13. That's 13. 14, 15, 16. So 12, 528. Is that normal? Not 12, it'd be 11. Yeah, I've got 498 as being normal on 11. So not too far off, but this is the part that here's that capacitor that blew up, you know, that we had to replace. I wonder if this diode is still good. I think I checked that diode, but this whole circuit took a hit, we know. Happy New Year. The IC did survive, yeah. Did the voltage go over 500? I hope not. That's getting into the scary territory. It's already drifted up to 12 volts there. That's just, it does that on its own. Beat that back down. It's kind of scary if that voltage goes that high. Are our resistors still good? 7.5 meg, 7.5 meg. There's a glob of solder that needs to go away. That needs to go far, far away. And make sure I didn't. Meg. What do I have on pin 2 as far as resistance to ground goes? That seems low. Let me short out this capacitor again and check it though. Now what do I have on pin 2? That's still low, 80 k ohms. It should be 95 k ohms. So we have this Zener here. You have this resistor to ground, you got a capacitor to ground on pin 2. And of course you have right over here through this 0 ohm jumper, Q34. And I'm thinking Q34 has broke down on us. me see if I can lift it. Oh, sorry, I keep popping my microscope. Q34. I'm just going to try to lift it and see if that resistance goes back to 95 k ohms. I'm thinking it will. This is part of that of the regulation for the PFC voltage. And this is a MOSFET that pulls that voltage to 0 to shut down the system. It's one of its shutdowns. All right, now with that off, pin 2. Oh, come on, if I can stay on there. 82K, we're still 82K. I don't like that. Making sure we don't have any DC voltage across that cap. 80K. I don't like that. That's not good. Has our zener gone bad? Has everything gone bad on this supply? I sure know how to pick them for a live stream. Why couldn't I just have some good simple ones, you know? Blown fuses or something. Exciting stuff. An exciting blown fuse. Oh, come on. I just wanted to lift that one leg of it. But it seems to have an endless supply of solder. I'm going to lift this and see if I get my 95 k ohms. I think I broke the leg. Whatever. I have these zeners. Not a problem. Do I have 95 k ohms now? I do. Or 96. Close enough for government work there. So my zener had broken down. ZD37. If you're curious where that is, ZD37 on pin 2. You have, this is your main boost voltage, 395 volts, right here. Two 7.5 meg ohm resistors, a jumper, a 0 ohm resistor or something, and then you have yeah, right there, ZD37, 8.2 volt zener. This voltage, it should be about 2.5 volts. When it's running perfectly, what it's trying to do is regulate 2.5 volts on pin 2. So this whole divider network is set up to yield 2.5 when you're getting 395 volts on that output. And this zener is going to be just to limit, you know, how high that can go. A ZD, I should have one of those. I should have a whole bag of them somewhere. Oh, I see them. How odd for me to actually see it right away. So many parts are out. Okay, I broke the leg on that one. It was bad anyway, so whatever. Doesn't matter, does it? There we go. There's my new one. Let's get rid of our old one. Let go. Turn the board a little bit where I can better get a hold of this thing. There we are. Brand new Zener stuck in there. All right. Is that the only problem? Load is still on. All right, let's give it a little bit of voltage. And make sure this doesn't go crazy. $12. Ta-da! Oh, my meter went to sleep. My meter got tired of waiting. We have picture. I can't believe. $12.12. She lives. Man, that's a lot of parts. Nothing on this side. Nothing on the cold side. Just all on the hot side. The PFC transistor survived, so that's one thing. But the controller IC and the MOSFETs for the 12-volt generation, a sack of Zeners, burned resistors, two burned blown capacitors. Soren is probably asleep. Yeah, I don't think Soren. Soren doesn't watch me anyway. It's working. I did forget to put that shutdown MOSFET back. You're right. I did leave a MOSFET out. That was a 704 MOSFET. So right now one of the shutdowns is disabled. So I should actually replace that. I guess that one's probably good. I think I'll replace it. I've got 100 of those. I think and they are common to go bad because they are connected with that 400 volt circuit. They don't see 400 volts directly unless a roach crawls across the board and then they see 400 volts directly. So that 704 MOSFET I did take off the board. Q34. Let's correct that. Sorry, I've got my cables tied up in my microphone. 704. Yeah. So I said normally what I would do when I have these parts bins, I put the part number and I put that little code at the end so I can just look up and see 704. But for some reason on that one I did not do it. So that MOSFET was probably fine, but I think I'll go ahead and change it because so many of them were damaged. Tweezers. I did take that MOSFET off. That one right there, Q34. Like I said, this I do remove this MOSFET quite often when I'm troubleshooting to disable the shutdown circuit so I can just see if that's what's holding it from running. But I never leave it out. I don't want to leave it out. It has a purpose. It needs to be in there. I thought I could do this with just the soldering iron. But yeah, I'll remove this one or lift one leg of it to disable the shutdown. Yeah, I got a lot of flux to clean up on this board, but okay, it's back in there. Because what that is, like I've gone over it before, that is the shutdown from the other side. If you know what I mean, that's the shutdown from the cold side of the board. Q34. I think that's right. Oh my God, do I have my MOSFETs messed up here? I think it's, yeah, that one, Q34. See, that's driven by this opto-isolator. So this is how this chip, the DMP014, sends a shutdown command. If it's over voltage on this side, over current, whatever, it just doesn't like anything, it will pull this low, and this comes over here. You know, this optical transistor is biased on, and then you get VCC, which is 18 volts, coming through over here into the gate of this, and this in turn shorts that sample voltage that should be 2.5 volts. It pulls it to ground, and when it does that, that's a command. That's one of the features of this chip, is that that's a shutdown command. If that voltage gets pulled to zero, that feedback, it instantly shuts it off. So sometimes you know that transistor will be stuck on or something that can happen. Anyway, let's make sure it still works. I'm thinking it does. Let's see. Yes, we're still working. We're still working. We're making 12 volts. Well, how long have I been streaming here? Because I am getting hungry and I think I want to go get some lunch. 2 hours, 48 minutes. So anyway, I'm going to call it off there. We fixed 2 of them. 2 out of 2 is not bad. I'll take that any day of the week. So, but anyway, Happy New Year to a lot of you people out there. It's not quite Happy New Year for all of us, but some of you it is. So Happy New Year. And hopefully I'll see you in the new year. And we'll fix some more PS5s and some power supplies, and maybe I'll get into laptops. I'm thinking about getting and working on some laptops if I can find some that are, you know, repairable. Not MacBooks probably, but so anyway, thank you for coming. And I'm going to go find some lunch. Happy New Year, guys and gals. And I'll see you next year. Bye for now.